We humans love beginnings. Birthdays, the first page of a novel, give us a starting line, and suddenly the story feels manageable. So it seems natural to think the Big Bang must mark time zero, the first tick of existence, the cosmic birth certificate. Makes sense, doesn't it? That's exactly what might be happening with the Big Bang. When physicists talk about it, they're describing the earliest moment where our laws of physics can still make sense. Earlier than that, our tools break down, equations start misbehaving. Predicting anything beyond that is like trying to measure the temperature of ice with a thermometer that only works above freezing. Reality doesn't stop, our description does. Here's the subtle but profound point. The Big Bang might be the first chapter we can read, not the first page of the universe. And yet, our intuition rebels. We translate first moment we understand into absolute beginning, because our brains are hardwired for beginnings in everyday life. So here's the unsettling question to carry with you. If the Big Bang is just the edge of our understanding, could the universe have already been running long before physics could even describe it? And if so, what does that mean for the idea of a beginning at all? We love to ask, what happened before the Big Bang? It feels natural, almost common sense. After all, every story, every movie, every life has a before. We look for causes, origins, first moments. But let's pause and think for a second. What's north of the North Pole? Or what's the day before January 1st? Those questions collapse under their own assumptions. The framework we rely on, direction, time, sequence, simply stops making sense. Our brains evolved to organize the world with timelines, cause and effect chains, and starting lines. It helps us navigate, survive, and predict. But the universe isn't obligated to fit our intuitions. Time may not be a pre-existing river flowing independently. It could be a property of the universe itself, emerging from space and the dynamics of reality, not a cosmic metronome ticking away outside. Imagine trying to measure seconds before clocks existed, or trying to track temperature before thermometers were invented. Those tools define meaning. Without them, the concept becomes slippery. Near the earliest moments, the universe, stable markers of change, oscillations, cycles, atoms, didn't exist. Time itself might be undefined, like asking what's up in the middle of a Mobius strip. And yet, we persist. Our language, our habits, our intuition push us to force the question, what was before? It's a trap. We are stretching words that evolved for apples, traffic, and birthdays into a cosmic context where they start to snap. So here's the unsettling insight. Before the Big Bang might not be a valid question at all. It assumes the very thing we are trying to understand. And if that's true, what does it even mean to talk about beginnings, causality, or time itself in a universe that refuses to conform to our everyday notions? Most people imagine the early universe like a tiny ball, squeezed into nothingness, ready to explode. It's a compelling mental image, small, dense, hot, waiting to ignite. Makes sense. Everything we know, from pebbles to planets, starts small and grows. But the universe doesn't follow the rules of our kitchen or backyard experiments. Picture zooming into a fractal image. No matter how far you go, you never reach an edge. The pattern continues endlessly. That might be closer to reality. The universe could have been infinite from the very beginning, just hotter and denser everywhere. Expansion doesn't imply it started small. It simply means distances between points increased over time. We assume smallness because every object we handle has boundaries. Every marble, every room, every city has edges. But the cosmos isn't a marble, it's a dynamic fabric. Its edges, if any, are not physical walls. They are the limits of what we can measure or describe. The universe might have stretched infinitely, and yet become cooler, less dense, and more structured as time went on. Here's a playful twist. Even if we try to picture a beginning, our brains cheat. We draw a starting dot, a cosmic spotlight, an origin point. Physics, however, laughs quietly. There may have been no starting dot, just an early state of extreme density everywhere at once. No center, no walls, No absolute smallness, just a universe full of potential, unfolding according to its own rules. So here's the mind-bending question. If the cosmos may have always been infinite, how do we even define the idea of a beginning? Could small and first be illusions that only exist in our imagination and not in reality itself? We take time for granted. Seconds tick, clocks tick, calendars flip. We picture the universe during the Big Bang as if time marched along like an obedient metronome. But here's the curious part. Time itself might not have existed the way we think, at least not in any familiar sense. Imagine trying to measure seconds before clocks were ever invented, or trying to measure a mile without roads. The tools that define meaning simply aren't there, and without them, the concept becomes slippery. In the earliest universe, stable, predictable processes, oscillations, atoms, cycles, didn't exist. How do you mark a second when nothing reliably repeats? The very idea of a timeline might not apply. Our brains are hardwired to see time as a flowing river because that's the world we evolved in. Rising suns, breathing, footsteps, they all have rhythms. But the universe doesn't owe us rhythms or ticks. Physics suggests that in extreme conditions, near the so-called beginning, space-time itself is a dynamic fabric, not a fixed stage. Seconds, minutes, and hours are emergent properties, not absolute measures. Here's the subtle thrill. The universe could have existed, changing and evolving, long before there were any meaningful moments to measure. Our insistence on a first tick, a starting line, is an artifact of our perspective, not a property of reality. So the playful, unsettling question arises. If time itself is part of the universe's story rather than the stage it plays on, then what does it mean to ask when the universe began? And if when doesn't even make sense, are we chasing the wrong kind of answer altogether? Here's a picture people love. The universe as a balloon, ready to explode into empty space. Space outside, matter inside, and everything rushing outward. Makes sense, right? That's how every explosion we know works. But here's the trick. The universe doesn't expand into anything. There may not even be an outside. Imagine a character inside a video game asking what's beyond the edge of the screen. From inside the game, the question doesn't make sense. The screen is all there is. That's what cosmic expansion might feel like from within the universe itself. There's no backdrop, no pre-existing emptiness, no cosmic wall waiting to catch galaxies as they fly outward. Space itself is what's stretching, carrying galaxies along for the ride. Our intuition rebels because it evolved to navigate surroundings, trees, rocks, roads. We cannot imagine everything without somewhere for it to be. Yet physics shows us that distances between points can grow without an external stage. Expansion is internal, not outward into a void. The universe is self-contained, and it doesn't need a theater beyond its own fabric. Here's the mind-bending insight. We keep asking, where is it expanding into? Because our brains insist there must be something beyond. But nature doesn't care about our intuition. There is no outside, at least not in the way we imagine. Space isn't a box, it's a stretching geometry. And so we are faced with a strange question. If the universe doesn't expand into anything, can it even have an edge? Or is our obsession with boundaries just another quirk of human thinking, trying to pin the infinite into something we can picture? When people imagine the early universe, they picture a blazing fireball, red, white-hot, chaotic, exploding, sparks flying, flames roaring. It's dramatic, it's cinematic, it even makes sense in everyday terms. After all, that's how we experience heat, a stove, a bonfire, the sun. But here's the subtle twist. The universe wasn't on fire. Temperature doesn't require flames. Heat isn't the same as burning. Imagine standing in a crowded elevator. Everyone's moving, bumping, shuffling, vibrating slightly. The closer the crowd, the more collisions, the more jostling. That motion is heat. No flames, no smoke, just energy and motion. That's closer to what the early universe was like. Particles and photons moving, bouncing, radiating energy. Hot, yes, but not fiery in the way your mind wants to picture it. We translate energy into fire because that's our human experience. But physics has a subtler story. Light stretches, particles collide, density is extreme, and radiation permeates space. That's heat without a match. The universe was dense, energetic, dynamic, but not burning like a kitchen stove. Here's the playful, unsettling thought. Our intuition loves drama, loudness, visuals. We imagine explosions and fireballs because we want a story, a sensory anchor. But the universe works differently. The Big Bang isn't a blowtorch moment. It's a state of extreme motion and energy, a kind of cosmic dance at a scale our senses can't directly perceive. So, if the fireball is just a metaphor, what does that mean for all the other images we carry about the beginning of everything? Could it be that our very desire for spectacle is leading us away from understanding the universe as it really is? We trust the Big Bang theory because it works beautifully. Galaxies move apart just as predicted. Cosmic microwave background radiation glows exactly where it should. Expansion rates fit. It's a stunning triumph of human curiosity and observation. And yet, here's the crucial point. A model is not reality. Think of a subway map. It's perfect for finding your way across a city. Colors, lines, connections, it tells you exactly where to change trains. But does it show the streets, the buildings, the smells, or the sky? No. It's useful, yes, but if you mistake the map for the city itself, you're in trouble. Physics works the same way. A theory explains patterns, predicts behavior, organizes observations, but it is never the thing itself. History is full of examples. Newton's laws explained motion perfectly for centuries. Then came small effects, then atoms, then relativity. The old model wasn't wrong, it was incomplete. That's the beauty of science. It improves, it expands, it doesn't pretend to be the final word. And that's why the Big Bang doesn't tell us where the universe came from or what lies beyond. It's a model of behavior, not a birth certificate. Space expands, matter cools, radiation stretches, but the model itself doesn't explain existence. Here's the playful, slightly humbling insight. We humans love certainty. We love neat explanations. We want the map to be the territory, but nature doesn't play by those rules. Our models are brilliant tools, but not oracles. They give us guidance, not guarantees. So here's the question that should keep you awake at night. If even our most successful models are only approximations, then how much of what we think we know about the universe is really just a story we tell ourselves to make sense of what we see? We've been walking along the edge of our understanding, peeking over the cliffs where our equations stop working. The Big Bang is not a birth certificate. It's not the loud beginning of everything. It's the boundary of the map we can draw. The first chapter physics can describe, the edge of our flashlight in the dark. Imagine explorers centuries ago, reaching the edge of the known world. The map ends at the ocean. Beyond it, blank space. Did they assume the Earth stopped there? Some probably imagined monsters, others filled in guesses. The blank space didn't mean nothing existed, it meant they hadn't explored it yet. That's exactly what science does at the Big Bang. The unknown isn't failure, it's an invitation, a place to marvel, a place to ask better questions. Science is honest about what it doesn't know. It says, this is where our story begins, but the story doesn't end here. And that honesty is a kind of courage. It's easier to pretend we understand, to smooth over the mysteries, to paint dramatic explosions and first moments. But true curiosity thrives where certainty ends. The universe doesn't owe us neat beginnings, tidy answers, or comforting first pages. It offers something infinitely better, a puzzle, a mystery, a space for imagination. Every time we reach the edge of our tools, we're reminded that reality is stranger, larger, and more beautiful than our words or pictures can capture. So here's the thought to carry with you. If the Big Bang is just where our map begins, and time, space, and beginnings themselves may not exist as we imagine, then what lies beyond the first page? And perhaps more importantly, can we even imagine it? Or is the act of questioning itself the most profound part of the adventure? So where does all of this leave us? The Big Bang wasn't an explosion. There may not be a center. Time itself might be a property that emerged with space. The universe wasn't a tiny ball expanding into nothing. It was a vast, dynamic fabric, stretching, evolving, behaving in ways that defy our everyday intuition. Every assumption we've carried about beginnings, before or absolute starting points, begins to wobble when we apply it to the cosmos. And yet, here's the beauty. That wobble isn't a flaw, it's the point. Science doesn't demand that we wrap the universe up neatly. It doesn't insist that we answer every question immediately. Instead, it celebrates curiosity, the willingness to say, "I don't know," and the courage to follow that admission into deeper questions. The edges of our understanding aren't walls, they're doorways. We are not failures because we don't have a final answer. We are explorers, peering into the vast unknown. Every limit, every uncertainty, every cosmic "I don't know" is an invitation to wonder, to question, to imagine what lies beyond our current map. The universe doesn't owe us clarity, but it does offer mystery, the kind that can change the way we see reality, time, and existence itself. So the last thing I want to leave you with is this. Don't settle for the comforting story of the Big Bang as a simple beginning. Don't feel the need to force the universe into a narrative that fits neatly on your calendar or in your mind. Instead, embrace the questions, sit with the uncertainty, and marvel at the fact that the universe is far stranger and more beautiful than any story we could invent. After all, the joy isn't just in knowing, it's in the adventure of trying to understand. And sometimes, the mystery itself is the most profound answer of all.